Hello learners, welcome to Form 4 Physics. This is your Msce Physics. Alright, for a number of weeks to come, we'll be looking at Form 4 Physics, Msce Physics. Alright, maybe before we start, let me take you through the topics that you are supposed to cover in Form 4 Physics. The first topic is called thermal expansion, which has to do with thermal properties of matter, in which you look at the fact that when matter is heated, it expands, and when cooled, it contracts. So that's the first topic, which we are going to look at in the Msce Form 4 Physics. The second topic is called Newton's laws of motion, as stated by Sir Isaac Newton. There are basically three laws that help us to understand the motion of bodies. So we are going to look at the first law, the second law, and the third law, and their applications. And then we move on to look at frictional force, the force that opposes motion, types of friction, and the applications of friction, and how you can also reduce friction. Then we look at springs and the bodies, the behavior of bodies such as deformation, as explained by Robert Hooke, in what is popularly known as Hooke's law. Then topic number 5 is a uniform circular motion, which is the movement or the motion of bodies in a circular path, and also its application. Then we move on to moment of force, which is the turning effect of forces. We progress to magnetism and the electromagnetism. These are related topics and their applications also. Then topic number 9 is electromagnetic induction, and then digital electronics. Right, topic number 11 is electromagnetic spectrum, which is a topic falling under the core element called waves and vibrations. Then topic number 12 is about light and lasers, also falling under waves and vibrations. Last but not least, we have a topic called nuclear physics. So in total we have 13 topics. So plan yourself in such a way that before you sit your 2026 exams, you've covered all these topics fully well. So welcome to topic number 1, which is called the thermal expansion. Thermal expansion. Alright, so as I always say, in order to unlock the understanding of any topic, it is important to define that topic. So let's understand the terms thermal. Thermal simply means heat. Okay, anywhere you see thermal, it means it has to do with heat. And then expansion. Expansion simply refers to increase in size. Increase in size. It can be increase in length, increase in volume. Alright, so what is thermal expansion then. We define thermal expansion as the increase in size of a substance on heating. And of course, thermal contraction or contraction is a decrease in size on cooling of a substance. Right? So we are saying that a substance will increase in size when heated. A substance will increase in size when heated and decrease in size when cooled. Think about a metal, for example. Suppose you have a metal bar. This is metal being heated at some point. Initially, the metal will have a certain length, call this length L. After some time, there's going to be a small change in length. Small change in length. Okay, you can call this delta L. So this small change in length due to heating is what is called expansion. So expansion is just an increase in size of a body when heat energy is subjected to it. When heat energy is subjected to it. So we'll make a deliberate statement that says that a substance increases in size when heated and decreases in size when cooled. So an increase in size of a body due to heating is called thermal expansion, while a decrease in size of the body when cooled is called contraction. All right, so related to thermal expansion, we have some concepts which we would like to make clear before we proceed. One of them is called temperature. Temperature, we shall define the term temperature as simply the degree of coldness or hotness of a body. Simply that. Okay? So a question that says define temperature. Don't go too far. Okay? Don't say many things. Just say temperature is how cold or hot a body is, or simply temperature is the degree of coldness or hotness of a body. You'll get full marks. Don't be cheated. You get 1 mark there. But temperature, the same temperature, is related to what is called the kinetic theory of matter of particles, or the kinetic theory of matter. Remember, in Form 3, you learned that the kinetic theory has to do with particles. It states that all matter is made up of tiny particles which are in constant motion. So, according to the kinetic theory of matter, particles of matter are always moving due to kinetic energy. Alright? So particles are always moving due to kinetic energy. So, in relation to the kinetic theory of matter, therefore, we can define temperature in the following manner. We can define temperature as simply a measure of the kinetic energy of the molecules of a substance. All right? You learned that when the temperature of a substance increases, the particles in matter or in the substance tend to move at higher speeds. All right, and remember that kinetic energy Ke is related to the speed of particles by the formula half mv squared. Okay, so this is what happens when you heat a substance such that its temperature rises. The value of V increases. Okay, in other words, kinetic energy depends on the temperature of the particles in matter. All right, so in relation to the kinetic theory of matter, therefore, we can say that the temperature of a substance is low if the molecules are moving slowly, and high if the molecules are moving fast. Okay, all right. So there are two ways to define the concept or the term temperature. One, as simply the coordinates and the hotness of a body or of an object, or it is a measure of the average kinetic energy of the molecules of a substance. Why? Because temperature affects the kinetic energy of a substance. The higher the temperature, the higher would be the kinetic energy of the substance, because the rise in temperature will cause a rise in speed of the molecules. All right. So the SI unit of temperature is called Kelvin. It's called Kelvin, named after one physicist called Lord Kelvin. Lord Kelvin is the one who came up with what is called thermodynamic temperature, which is measured based on the Kelvin scale. But in your lab, most of the times you are going to be using a unit which is called the degrees Celsius. However, from your Form 3 physics, you must know that 1 Kelvin of temperature is as good as 273.15 degrees Celsius. That's very important. Okay, or to make it a bit simpler, 1 Kelvin, to change the temperature in which is in degrees Celsius, the temperature which is in degrees Celsius, to change this into Kelvin, all you have to do is just to take you a bit back to Form 3 physics. All right, so to change temperature in kelvins, all you have to do is take the temperature in degrees Celsius and to each add 273.15. All right, so you're going to have temperature in kelvins. For example, if the temperature of a body is 25 degrees Celsius, 25 degrees Celsius, suppose it's 25 degrees Celsius. So in kelvins, it is going to be 25 degrees Celsius add 273.15. Right, so this will give you 298.15 kelvins. Just to remind yourself about these conversions to Form 3 physics. And it also follows that temperature in degrees kelvins, in degrees Celsius, is going to be temperature in kelvins minus 273.15. So you subtract, in order to change temperature in kelvins to temperature in degrees Celsius, just subtract 273.15. In some cases, you may not have to include the decimal part. Just say 273 is fine. It's accepted. All right, that's very good to note. So your syllabus requires you to distinguish or to differentiate between temperature and heat. You can have a 2 marks question that says distinguish between heat and the temperature. What are the differences between heat and the temperature? By now, you should know that heat is a form of energy which passes from a body which is at higher temperature to a body which is at a lower temperature. All right, so let's suppose that we have two bodies which are in contact. Call this body A and another body B. These two bodies are in a thermal contact with each other. Suppose body A is at a temperature of body A is a temperature of 25 degrees Celsius and body B is a temperature of 45 degrees Celsius. So heat is going to flow from a body which is at higher temperature, in this case B, to a body which is at lower temperature, which is A. So the direction of heat flow is going to be like that, from B to A. All right? So you should understand that heat is a form of energy. Okay, like all other forms of energy, it's measured in units called joules. All right, so we are saying that heat is a form of energy which passes from a body of higher temperature to a body of low temperature. Okay, the SI unit of heat is the joule, while that of temperature is a Kelvin. So the SI unit of heat energy is the joule. All right. Temperature, on the other hand, is a degree of hotness or coldness of the body. So it's basically a measure of heat energy of the molecules in a body. Okay, so if you are to tabulate these differences, let's suppose we have temperature on the one end, temperature, and then we have heat energy. You want to give differences. So temperature is coldness or hotness of a body. Heat is the energy of particles. Temperature is measured in kelvins or degrees Celsius if you want. Heat is measured in joules. So take note of these key differences, because your examiners will require you to, I'm sure you have seen questions like that in Msce papers, asking you to differentiate heat and temperature. So we are saying when you're giving differences, you can use the definition of the two terms. Heat is a form of energy which passes from a body of high temperature to a body of low temperature, while temperature is the degree of hotness or coldness. Okay, the SI unit of heat is the joule, while the SI unit of temperature is the Kelvin. All right, so what is the effect of expansion, or rather what happens during expansion, thermal expansion? So when a body is heated, all right, three things can happen. Okay, let's suppose that we have a body which is being heated, supply heat at some point here. So this is just a body or an object, and it's being heated there. All right, so we're saying three things can happen. One of the things is that the body can increase in length. So there's an increase in length. The body will increase in length, so length increases, but it can also increase in volume. It can increase in volume. Remember that volume is the amount of space which a body takes up. Okay, so volume can increase, but also area can increase. So three things can change due to heating. So a body can increase in length, it can increase in volume, it can also increase in area. Remember, area is the length multiplied by width, okay? And the volume is length multiplied by width multiplied by height. So these dimensions can change due to heating. So they will ask you in an exam to say, state two things that change in a body when it is heated. So you mention increase in length, increase in volume, and increase in area. And the opposite is also true. If the body is contracted, like it's cooled down, it means these same dimensions will also decrease, which in a process called contraction. All right, so very important to note. All right, so for now, let us break and we'll come back to look at some experiments that could be done to show that bodies expand when heated and they contract when cooled. If you are just new to the channel, consider to subscribe so that every time a new lesson is uploaded, you are the first ones to know. Once again, my name is Mr. Pochilola. Wishing you the best. We meet again in the next lesson where we are going to look at some experiments related to